now that we are introduced to the physics engine, yeah, especially in Unity, we know the components to activate the physics simulations in Unity. Now let's try to revisit our kinematics simulation. Yeah, we will re-implement the kinematics using the Unity physics engine. Yeah, please create a new project. Yeah, and name it Hello Physics. I have created my Hello Physics over here, and then let's rename this sample scene name. Yeah, I will rename it into KLP. Yeah, we will try to implement KLP first, and then we'll move on to KLPP. For the projectile motion, please implement it yourself, yeah, because if you remember, last week I asked you to implement the projectile motion for yourself, yeah. The same as today, for the projectile motion, you must implement yourself using the newly gained knowledge, yeah, that is using the rigid body. Okay, and then please re-import all the sprites we used before to the assets sprites folder. Yeah, let's import car, target, and folder. Okay, I will create my folder first, sprites, and then I will to import car, folder, and target as well. Yeah, and then let's add the car cam object as usual. I will expand the hierarchy first for my KLP, and then I will drag my car sprite to the hierarchy. Yeah, let's scale it maybe a half of the original size, and I will put it over here. Let's scale it to 0.3. Okay, that's nice. Yeah, and then let's add the rigid body component. Yeah, how to do that? It is very simple. Yeah, make sure your car cam object is already selected. Then at the inspector panel, yeah, scroll down until you find the add component button. Yeah, just click it and then search for rigid body. As you see here, I have already searched for rigid body, yeah, in my previous projects. So Unity greets me with two rigid bodies. One is rigid body and the second is rigid body 2D. Yeah, be careful about this because Unity has a separate physics engine for 2D and 3D games. Yeah, for 2D games, you want to use the rigid body 2D. Yeah, not the rigid body. Rigid body is used for 3D games. Okay, so select rigid body 2D. Yeah, and you will get a new component, something like this. Yeah, ignore it for now. Let's talk about the rigid body components first, yeah, before we try to modify some properties later. Yeah, a rigid body 2D is a component to make the game object adhere to the physics law. Yeah, what we call physics law here, of course, it is determined by the implementation of the physics engine. Yeah, in Unity 2D, it uses the Box 2D physics engine. Yeah, so to use a physics engine, you simply add the rigid body 2D component to any objects, yeah, that will need features of the physics engine. It's as simple as that. Okay, if you try to run your game right now, yeah, I will try to play my game. You will see that my car immediately falls down. Yeah, so congratulations, you have just simulated free fall motion. Yeah, it is much simpler compared to last week's, yeah, when we implement ourselves by using the script KLB, but we modify it to the y-axis. Yeah, in Unity, it is as simple as adding the rigid body to the component. Yeah, but why did our car fall down? Was there any gravity somewhere? Yes, of course. Yeah, let's talk about the properties of our rigid body. Yeah, we are now interested in only two properties. Yeah, the other properties will be explored later as we see fit. Yeah, for now, let's just focus ourselves to two properties. Yeah, the first is mass. Yeah, simple. The mass defines the object mass. Yeah, we can set the mass of any game object automatically to follow the collider by checking the use auto mass. Yeah, over here. Yeah, but usually I don't use this option, use auto mass. Yeah, I will leave it 1 by default. Yeah, the mass unit in Unity is kilogram. Okay, the next one, the gravity scale. Yeah, it controls the gravity multiplier. Yeah, what is the value of the gravity in Unity? Yeah, we can check in this menu. Yeah, but Unity uses the default value of gravity as we have previously looked at the last 2 weeks. Yeah, we know that the gravity is 0 to the x-axis and a negative 9.81 to the y-axis. Yeah, Unity uses the very same value as the Earth's gravity. We can check it in the menu edit and then sorry, not preferences, yeah, but project settings, edit, project settings, and then select physics 2D. Yeah, you will see that the gravity value is 0 to the x-axis and negative 9.81 to the y-axis. Yeah, of course, you may modify the value as you wish, yeah, but for now, let's just leave it as it is. Yeah, we will use the Earth's gravity. Okay, how to turn off the gravity? It is very simple, yeah, but we must do it per game object. Yeah, turning off gravity is done per game object. Simply set the gravity scale to 0. Yes, this way, our car will no longer affected by gravity. Yeah, as you can see here, my car is no longer affected by gravity. It will not fall down like it did before. Okay, to simulate kinematics using rigid body, yeah, we have 3 steps over here. Yeah, the first step is to prepare a private rigid body 2D field to be used as the reference to the rigid body 2D component. Yeah, because we want to modify this component via script, we need to provide a field. Yeah, and then we will get the component in the start method. Yeah, we will only do this once. Yeah, that's why we do it in the start method. Yeah, remember, start is called when the game object is loaded to the scene. And then for the third step, if needed, we will manipulate the rigid body in the fixed update method. Yeah, now you are introduced to a new method here. There is a fixed update. Yeah, maybe you wonder why not in update. Yeah, if you recall, update is called once per frame. Yeah, however, the update method is prone to the frame rate of your game. Yeah, this means that if your frame rate is actually high, yeah, let's say our frame rate is currently 100 frames per second. Yeah, it means the update method will be called 100 times per second. However, if our frame rate dips below, yeah, for example, let's say now our frame rate is only 50 frames per second. That means that the update method will be called less frequently, yeah, which is only 50 times per second. Yeah, so as you can see, update is volatile here. Yeah, it is not very stable, uh, very dependent on our frame rate. Yeah, so for physics simulations, it is not really a good idea to use the update method. Yeah, if you remember from our previous Unity projects, yeah, we used the update method to simulate our simulations. Yeah, now you can check if it is correct. Yeah, if all of our simulations are correct. Yeah, later please check it by yourself. Yeah, for now, yeah, Unity recommends using a fixed update method for physics related calculations. Yeah, as you can see here, as opposed to update, yeah, fixed update calls are performed in the same interval or uniform time steps here, which means that our fixed update method will be called every 0.02 seconds or 50 calls per second. Yeah, so fixed update is set to 50 frame per second. Yeah, as opposed to update, which is a variable frame rate. Yeah, therefore, please remember if you want to manipulate your Rigidbody, please do it in the fixed update method. Yeah, now we have the transform component as well. We will use the Rigidbody component. Yeah, and then which one to choose? Yeah, will we want to simulate the transform or we manipulate the Rigidbody or both? Yeah. If you remember before, we manipulated the position and the rotation of our game object by manipulating its transform component. Yeah, however, when using Rigidbody component, yeah, we will use force to create a realistic, yeah, or actually not realistic but believable movement. Yeah, and Unity says that manipulating the transform in the same time as Rigidbody will actually confuse the physics engine. Further, it may result in incorrect simulation. Yeah, so Unity warns us, yeah, please don't manipulate transform directly if you are using Rigidbody. Yeah, what does this actually mean? We will see later when we implement GLB, GLBB, and later you will implement projectile motion by yourself. Okay. Yeah, now that we have known about the Rigidbody component in Unity, let's start simulating or actually create a new simulation. Yeah, for our kinematics, but now we will use Rigidbody. Okay, first we will try to simulate KLB. Please create a new script. Yeah, for now name it car RB. Yeah, RB stands for the Rigidbody. Create folder first, scripts, and then I will create my script car RB. Yeah, and then I will immediately attach my car RB script to my car game object. And then let's edit it. Yeah, while waiting my Visual Studio to be ready, yeah, if you have, so yeah, please add these three fields. You may want to type using TM Pro first, yeah, for the user interface. Yeah, actually we have not created our user interface, but the UI is actually the same as the GLP simulations previously. Okay, we will skip that first for now. Yeah, let's try to create the car script first. Okay, so prepare a TMP input field for the speed input, and then two private fields, yeah, float speed. But now we have a new member that is a Rigidbody 2D RP. Okay, I will edit public TMP input field speed input. Oops, sorry, speed input, and then Rigidbody 2D. Rigidbody. Oh, sorry, Rigidbody 2D. Oh, I think there is a typo in the slide. Yeah, the B should be in lowercase. Yeah, let me correct it for you first. Yeah, it is Rigidbody 2D. Yeah, with lowercase b, not the uppercase b. Yeah, Rigidbody 2D RB, and then float speed. At the start method, let's initialize the speed to 0 and get the rigid body to the component. That is actually also has a typo here. Let me correct it first. Rigid body with the lowercase p, yeah. Okay, speed equals to 0, and then RP equals to get component home, not really the garbage collector, yeah. Get component rigid body to T. We only need to do this once. Please don't call get component in a method that is called frequently, yeah, such as update or fixed update. Yeah, because get component is actually costly. Yeah, Unity needs to scan for any components in a specified game object, yeah, and then get the correct component. Yeah, this is costly, so only do this once, preferably in the start method. Okay, and then for the set speed, this is the very same as our previous GLB card script. Yeah, I will just type it instead. Public void set speed. And then the content is speed equals to float.parse from the speed input dot text. Okay, now what about the velocity? Yeah, remember that in GLB, an object moves in a constant velocity. Yeah, the rigid body component has a velocity field. Yeah, in vector 2 that we may use for this purpose. Yeah, so on the set speed method, please add this bolded line. Yeah, to set the velocity of a rigid body, simply call the velocity field from the RP field. Yeah, and then we will set it to vector2 dot right. Vector2 dot right. Yeah, this is a shorthand for the vector unit to the x-axis. Yeah, in the same manner, we have also vector2 dot up, which is a unit vector in the y-axis. Simply multiply this by speed, and then we're done. Yeah, that's all. Very simple, right? We no longer need to implement the code to move our game object by ourselves. Yeah, if you recall, we coded in the update method. Yeah, since our update is now empty, let's remove it. Save your car RP script, and then please prepare this user interface. Yeah, this is a TMP text, TMP input field, and TMP button. Yeah, I will also create my user interface. Yeah, UI text mesh pro. If you have not done so, please import TMP essentials first. Okay, where is my text? Oh, it's over there. Yeah, and I will change my UI scale mode to scale with screen size, and I will use my favorite reference resolution, yeah, 1366 by 768. Okay, I will put it over here, maybe at this length, yeah, 300. I will change the text velocity, make it centered, and then I will add an input field, also text mesh pro. So it's over there. Let me drag it over here. Yeah, I will make it the same size with my velocity text. Now, I think it's a good idea to move it upward. Okay, maybe something like this. For the font, I don't think it's readable. Yeah, it's not readable for the placeholder. So let's try to increase the font size, maybe 28. Okay, then that's nice. 28. And for the text itself, I will also make the font size 28. And then this is optional. Yeah, but I will make my input field only receives number. Yeah, so I can change the content type into either integer or decimal number. Yeah, this way I can prevent the user to input any other inputs such as characters. Of course, if you try to parse any characters into float, you will get an error. Yeah, so I don't want that. I can restrict my input field to only receive decimal number. Yeah, but this is optional. You don't really have to do this, yeah, unless you are very certain that your input is actually a float. Okay, the last thing I need to do is to add the button. Yeah, Text Mesh Pro. So I will drag it over here. Oh, sorry. Drag it over here. Make it the same width. Yeah, and then let's change the text to what is it? Yeah. Oh, start. Okay, start. If you want, you can rename the button. Yeah, but I won't do that here. Font size is 24. I think it's readable enough. For the input field, I will rename it speed input. Oops. Oh, sorry. I clicked the wrong field. Speed input. Yeah, and then please specify the speed input to this speed input field. And of course, add the on-click listener for your button. Yeah, I hope you have already known how to do this. Okay, I think everything is set. Let's see. Yeah, our car is not moving right now. But if I input any velocity such as 2, and then I click start, yeah, as you can see here, my car moves in constant velocity, that is 2 unit per second. Yeah, or I can say it is moving with a velocity of 2 meters per second. Okay, that's all about KLB. Yeah, if you have any difficulties or any questions, yeah, please don't hesitate. Use your Hangouts group chat, or for the others, you can also ask me in the comments below. Okay. Now about the KLBB. Yeah, let's try to simulate KLBB. Save your scene and then duplicate it. Yeah, you can duplicate anything in Unity by pressing Ctrl and D. Yeah, you will get KLB1 over here. Rename it to KLBB and then open it. Yeah, make sure you open the KLBB before doing this part. Yeah, for the GLBB, we will need to add a new Text Mesh Pro, text acceleration, and then the input acceleration, as well the current velocity. Yeah, let's do this first before we modify the car RP. Yeah, okay. Let's do the user interface. Yeah, to speed the whole process, let's just duplicate this text and split input. Yeah, duplicate, and then I will use my move tool to move them over here. Yeah, and then I will go back to my rect tool. I will change this text to acceleration. For this one, it's acceleration input. Acceleration input. And then we have, oh, current velocity. Okay, I will duplicate this one. And then I will move it to the right. Yeah, for shortcut, you can also press W to immediately activate the move tool. Yeah, and then for the rect tool, the shortcut is T. Yeah, so actually all of these tools over here have the shortcut Q, W, E, R, T, and Y. Yeah, so if you cannot remember it by now, you can just press Q, W, E, R, T, or Y until you get the tool you want. Okay, for the acceleration, it is changed to current, current velocity. And we have the current velocity at the bottom of this text. Yeah, so I will duplicate it again, move it maybe over here. Okay, that's nice. I will change this to the I will rename it to velocity text. Yeah, as a placeholder, I will give it 0, and then let's make it left aligned. Oh, I don't think it's aligned nicely. So, okay, for the current velocity text, I will also make it left aligned. Okay, nice. Yeah, I think that's all for the user interface. Yeah, and then for the script, let's also duplicate the car RP script. Yeah, if you don't want to duplicate, yeah, because if we duplicate, we need to rename and then also rename the class name. Yeah, you can also create a new script instead. Yeah, but this time, let's try to duplicate the script. Rename it to car RPXL. Yeah, and then edit your car RPXL because we need to change this class name to car RPXL as well. Yeah, be careful about your class name. Yeah, it should be exactly the same as your C# script file name. Yeah, including the casing. Yeah, it should be in the very exact same casing. So if you have the car RP Excel class with the C, R, P, and A, all of them are in the uppercase. Yeah, your class name should be also use the C, R, P, and A in uppercase as well. Yeah, please be careful about that. Okay, and then we need to add a new TMP input field for the acceleration input. Acceleration input. And then what else? Yeah, we will need new TMP text to show the current velocity. Okay, let's edit public TMP text velocity text. Okay, float acceleration as well. For here, I will edit acceleration Also initialize your acceleration to 0. And then the preparation of this car RP axle is done, I think. Yeah, we're done. And then for the fix update method, yeah, the rigid body does not have the acceleration field, unfortunately. Yeah, we don't have acceleration here, so we must simulate the acceleration by, oops, sorry. Yeah, we must simulate the acceleration by ourselves. Yeah, this is not actually not the preferred way to simulate the acceleration. Yeah, to simulate acceleration in Unity, it is preferred to use force. Yeah, but we haven't learned about force. Yeah, we will try it next week. Yeah, after we have learned about force. Yeah, so for now, we will try to simulate it manually, but still using RP. Yeah, please add the fix update method. If you have installed game development with Unity tools in Visual Studio, we can just use the implement Unity messages to add any Unity methods. Yeah, in this case, we want to add the fixed update method. Okay, how to do that? Place our cursor in any empty space inside the car RP Axle class. Yeah, and then press Ctrl Shift and M. Yeah, if you can't remember the shortcut, you can just right click over here and then choose implement Unity messages. Yeah, the shortcut is Ctrl Shift and M. Yeah, and then search for the fixed update method. Yeah, it is actually over here, so I will just take it instead. Yeah, if not, you can always filter it over here. Yeah, fix update. Then tick the fix update and click OK. Yeah, this way the Visual Studio will insert the appropriate Unity message declaration. Yeah, here the header is private void fixed update with F and U, both are in uppercase. Yeah, if you type it yourself and you make a very slight mistake by writing the U in update is in lowercase, then your method will not work. Yeah, so adding the Unity messages by using implement Unity message is preferable. Okay, let's add this to our fix update. Yes, speed, oops, sorry, speed plus equals acceleration times time dot delta time, like we did in our previous GLBB simulation, yeah. But this time, we do the very same thing as our car.rp. Yeah, we will set the velocity equals to factor 2.right times speed. Yeah, that's all. And then let's display the current velocity in the velocity text equals to rp, oops, sorry, rp dot velocity dot to string. Yeah, alternatively, you can also display the speed here as in the slide. Yeah, speed dot to string. I will display the rp dot velocity instead. Yeah. Okay, I think that's all. The last part before we try our script. Yeah, let's modify the set speed method to also take the acceleration input into account. Okay, so here, let's remove this. Yeah, actually, oh, that's fine. RP dot velocity here is equals to factor 2 dot right times speed. Yeah, this means that our car has the initial speed of this. Yeah, and the acceleration as written or as input in this input field. Yeah, that's fine. Okay, I will put it over here. Acceleration equals to float dot parse from the acceleration input dot text. Yeah, I think that's all. Let's try our script. Make sure you have saved your car RP Excel script. Yeah, I have saved it. And then set everything as usual. Instead of the car RP script, we must attach the car RP Excel script. Yeah, to do that, just simply drag and drop the car RP Excel script to your car. Yeah, and then you can safely remove this component. Okay, and then set up everything. Speed input, acceleration input, and the velocity text. Yeah, and then for the button on click listener, we must set it again. Yeah, because the component is now missing. Okay, car RP acceleration, and then set speed. Yeah, let's try our simulation. I will input the current velocity or initial velocity as 0, and then I will give the acceleration of 1. And let's see what happens when I click start. Yeah, as you can see, now our car moves faster. Yeah, if you see here, yeah, Unity displays my rigid body's velocity, yeah, x and y. Yeah, the y component is always 0 in this case. Okay, let's try it one more time. I will input the velocity of 1. I'll give it acceleration of 5. Yeah, that is the result. Okay, so that is the implementation of GLBB using rigid body. Yeah, it is simpler than we implemented ourselves. Yeah, as you can see here. If you have any questions, yeah, maybe you have any difficulties, any errors, yeah, please ask me right away. Okay. And for the last part, for the projectile motion, please implement yourself. Yeah, if you want, please submit your modified projectile motion, yeah, using the rigid body, and I can check it for you. Okay, so I think that's all for now. Yeah, we have implemented the kinematics movement, yeah, using the newly gained knowledge, yeah, using the Unity's physics engine by attaching a rigid body 2D component to our game object. Yeah, and then by simply manipulating the velocity, we can already simulate the KLB movement. Yeah, as simple as this. Only rigid body dot velocity equals to some factor 2. For the acceleration, yeah, it's the same. Yeah, but you need to increase the velocity by the acceleration. For the freefall motion, we have implemented firstly when we tried our rigid body, yeah, simply by setting the gravity scale to 1. Yeah, now the remaining movement is the projectile motion. You can implement it yourself. Okay, that's all for today. Next week, we will talk about Newton's law. Yeah, we will introduce ourselves to the concept of force. I'll see you again next week.